أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله. I welcome you all to the channel again. Our topic today is types of motion, and this class is for senior secondary schools 1 first term week 5. I the presenter am Shuaibu Muawiyah Salenkano. Today being Saturday December 30th 2023. Performance objectives. These are activities that students should be able to do at the end of this lesson. At the end of this lesson, students should be able to, number one, explain the meaning of motion. After listening to and watching this video, you should be able to explain the meaning of motion. Secondly, you should mention the types of motion studied in physics. And thirdly, give at least 2 examples for each type of motion. Now, we will begin by explaining the meaning of motion. What do we mean by motion? Meaning of motion. Motion involves a change of position of a body with time. Motion involves a change of position of a body with time, meaning if the location of an object changes as time changes, we said the object is in motion. If time is changing and the location of an object is not changing, its position in space is not changing, then we say that that object is not in motion. We quickly move on to see the types of motion we have. Types of motion. The first one is random motion. In random motion, objects move irregularly, or you say haphazardly or disorderly, with no preferred direction or orientation, meaning all the particles, all the particles in the body are not moving in the same direction. They move in different direction. If some particles are moving in the eastern direction, others will be moving northward, eastward, and on and on. Particles collide with one another. There is collision between the particles as they move randomly. Here are examples of random motion. The first one is Brownian motion. The Brownian motion was studied by a scientist, Robert Brown, and this is why we use his name in order to honor him. And what do we mean by Brownian motion? Brownian motion is an irregular motion of particles suspended in water, smoke particles suspended in air, or in the motion of gas particles. The second example is motion of insects such as bees, houseflies, butterflies, etc. We will see these examples in photos. Look at the first photo here. Let's say I have a particle here, and this is the starting point. It moves in this direction, and then it changes direction and moves this way. It changes direction again and moves this way. It changes direction again and moves this way, and on and on and on. And at the end, it ended here. And so you can see that there is no preferred direction. The direction keeps changing constantly. This is why we call this type of motion random motion. And let's say this is a gas sample, okay? And you have tiny particles. Each dot you see here, each of these balls represent a particle in a gas. You can see that every particle you take, it moves in a different direction. This particle moves in this direction, this particle in this direction, this particle in this direction. So they end up colliding with each other. Because there is no single direction faced by each particle or by all particles, they do not move in the same direction. This is why we call it random motion. This is the random motion of butterflies. You can see you have 3 butterflies and they face different directions. The second type of motion is translational motion. A motion in which all points of a body are moving uniformly in a single direction. This is like the opposite of random motion. In random motion, they move in different directions. But in translational motion, they move in the same direction. When an object undergoes translational motion, there is no change in its orientation. Translational motion is sometimes called rectilinear motion, especially when the path is straight, when the rod is straight. We call it rectilinear motion. Here are a few examples of translational motion. The first one is a car or a train moving along a road. Okay, this is a translational motion. It moves from one point to another point. Motion of a bullet fired from a gun and parade of soldiers. We will see these examples in images. Here we have translational motion of a car along a road. Here is the car. It moves from one point to another along a road, and this is why we call it translational motion. A single direction is involved. Again, we have translational motion of a train along a track. It moves from somewhere here to somewhere here along the same direction. Thirdly, we have translational motion of a bullet fired from a gun. You can see the bullet was somewhere here. When fired, it moves all the points in the bullet. Every particle in the bullet is facing the same direction, and it is transferred from a point somewhere here to a different point here. We also have parade of soldiers. Translational motion in a military parade. You have soldiers here and they all march in the same direction. This is another example of translational motion. The third type of motion is rotational motion. This refers to the motion of an object around a circular path in a fixed orbit. Rotational motion is also called circular motion. We will see the examples and the images as well. Examples of rotational motion. The first one is the rotation of fan blades. Secondly, rotation of the hands of a clock. Thirdly, Earth rotating about its axis. Fourthly, we have Earth orbiting around the Sun. And finally, we have spinning of a DVD. We will see these examples in images. Here we have a fan blade. This is a blade, this is a blade, this is a blade. The three blades are moving. The kind of motion is rotational motion about the axis. The axis is a straight line at the middle here. You can see the line here. We call it axis of rotation. Rotational motion of fan blades about their axis. This line, okay, this straight line here at the middle is what we call axis. Here is rotational motion of the hands of a clock. As we can see, we have this hand, this hand, this hand. All of them are rotating about a fixed point, and this is the fixed point here. The middle here is the fixed point. Moving on, we have the earth here. You can see that this portion of the earth is facing the sun, is receiving the sunlight. That is why it is the day. This is not facing the sunlight. It has darkness, and that is why we have the night. And the earth rotates like this. As you can see, it rotates like this. So it is because of this rotation of the earth that if now is day, after a few hours I will see night. If the earth is not rotating about its axis, then one portion of the earth will permanently be day and another portion will permanently be night. While the earth is rotating about about its axis, the axis is a line that passes through the center of the earth. This is the earth. You see, this is the axis of the earth. This line that you see here, it is rotating, and at the same time it is also orbiting round the sun. This orbital motion, okay, is also called rotational motion. As you can see here, Earth orbiting around the sun is also an example of rotational motion. Here is a is a figure that shows planets orbiting around the sun at different speeds. If you observe the figure closely, you will find out that the planets that are closer to the sun, okay, they orbit at greatest speed. Look at Mercury here. This is Mercury. Let me make this large so that you can see this. This is Mercury, the first one. It orbits with this speed, 47.87 kilometer per second. And the next one is Venus, 35.02 kilometer per second, meaning in 1 second it covers a distance of 35.02 kilometers. This is the Earth where we live in. It orbits the sun with a speed of 29.78 kilometer per second, meaning every 1 second it moves around the sun and covers a distance of 29.78 kilometer in just 1 second. Now this speed is decreasing constantly, and the last one you can see, Neptune, it has a speed of 5.43 kilometer per second in just 1 second. This is the least of all the speeds. Then we have the spinning of a DVD. If you have a DVD here, okay, it will be moving in, it will be rotating. This is another example of rotational motion. The fourth example is curvilinear motion. Curvilinear motion. Curvilinear motion is a type of motion that occurs when an object moves along a curved path. We will see the examples. Okay, examples of curvilinear motion: motion of a ball when kicked, motion of cars along a curved road, motion of athletes along a curved race track, motion of a roller coaster train or car along its track. Here are the examples in images. This is curvilinear motion of a football when kicked. If you kick a football during a free kick, look at the path it follows. It doesn't follow a straight path. The curve is bent. Okay. This is why we call it curvilinear motion. And you also have curvilinear motion of cars along a curved road. Can you see that? The road is curved and the cars are moving along the curved road. This is another example of curvilinear motion. We also have motion of athletes along a race track. This is the race track, and here are the athletes. They all move along the curved path. That is why we call it curvilinear motion. And then you have curvilinear motion of a roller coaster train. You can see the path it followed. Somewhere here, this is curved and it goes down here, up here, down here, up here again, coming down. The path is a curved path, and this is why we call the motion curvilinear motion. The fifth type of motion is oscillatory motion. This is the to and fro motion of the body about its fixed position. The body has a fixed position where it is initially before the motion started. When the motion started, it moves to the left and comes back to the fixed position, and then goes beyond it and moves to the right, and then comes back to the fixed position, and then moves to the left and comes back to the fixed position and moves to the right and comes back again. It does that again and again, repeatedly. This is why we said oscillatory motion is a type of periodic motion, because it repeats itself after every given fixed time. We will see the examples and the images. Examples of oscillatory motion. The first one is swinging of the swing. The second one, vibrating mass on a spring. The third one, vibration of plucked guitar strings. The fourth one, vibration of the prongs of a tuning fork when struck. Now here are the examples in images. This image shows oscillatory motion of swings with children. You see, you have a swing here. Before it started, it was at rest, vertically at rest. Then when the swinging started, it moves. That initial position was the fixed position. Okay, now it moves forward and then comes back to the fixed position, then moves backward, comes back to the fixed position again, moves forward, comes back to the fixed position again, and it does that again and again. Okay, this is why we call it oscillatory motion, to and fro motion. Next, you have the mass spring system, oscillatory motion of a mass suspended on a spring. Here is the support holding the spring and the mass. You have the spring here and you have the mass here. Now, if you place your hand on the mass and press it downward and then release it, it goes up and down, up and down. This position before you press, this position here is the fixed position. Now, when you press it down and release it, it goes down, up, down, up, down, up about this fixed position, and this is why we call it oscillatory motion. This motion is also called vibratory motion. Here is oscillatory motion of plucked guitar strings. If you play guitar and then you pluck the string, it moves up and down, up and down, up and down, up and down about its fixed position. This is also a kind of oscillatory motion. Then you have the prong. This is what we call tuning fork. If you hit the prongs, okay, of the tuning fork, each prong here will be vibrating this way, this way, this way, this way. It will be vibrating, and this is why we call it oscillatory motion. Oscillatory motion of the prongs of a tuning fork when struck. The last one is relative motion. This refers to the motion of an object or observer relative to a chosen frame of reference. We need an explanation for this to make it clearer. Okay, this is why we said here, before giving example, we say explanation of relative motion. If you look outside the glass of a moving car, you will observe that another car lying stationary appears to be moving in a backward direction. You are in a car, the car is moving with you in a particular direction, you stand up and looked backward, you look at the glass, okay, you saw a car that is at rest, but that car appears to be moving in the opposite direction, backward. How does a stationary car seem to move? This is the idea behind relative motion. When we say an object is in motion, it must be with respect to a frame of reference. We mean this frame of reference is the one we use to measure motion of an object, the position of an object, the velocity, speed, acceleration, all these kinematic terms, we measure them using a frame of reference. Without this frame of reference, you cannot make any such measurement. So we need a frame of reference. In everyday life, when we consider the motion of an object, the frame of reference is taken to be the ground or the earth. So if you say a car is moving with a velocity of 60 km/h, your frame of reference is this earth, is the ground. Okay? So examples of relative motion. If you examples of relative motion. Examples of relative motion. If you are traveling in a train and the train is moving at a speed of 100 km/h, then your speed, according to another passenger sitting on that train, is sitting with you on that train, is zero, because to him you are not moving. So you have a zero speed. Okay, according to him you are not moving, but if someone observes you from outside the train standing on the ground, according to him you are moving at 100 km/h. You see what we are saying? As you are on the train and the train is moving at 100 km/h. So we need to know relative to what are we observing your motion. If it is relative to the car, then you are at rest in the car and you are not moving. Relative to the ground, of course you are moving with the speed of that car, 100 km/h. So we have two things involved: your motion relative to the car is not happening because you are stationary. Your motion relative to the ground, of course you are moving, and you move with 100 km per hour. Okay, here is the illustration. You are here sitting in a car, and this car is moving with a velocity in this direction. So this is an observer. To the observer, of course you are moving. If we are measuring your motion relative to the ground, meaning our frame of reference is the ground here. To us here, observers in the ground, you are moving relative to the ground. But if we have another observer here inside the car, to him you are not moving. Okay, if our frame of reference is inside the car, you are not moving. If the frame of reference is here outside the car, of course you are moving. And this is why sometimes we observe that when we are moving in a car, we see trees seem to be moving with us, because our frame of reference is the car, and that is why we see them as if they are moving. But if the frame of reference is the ground, they are not moving. We call this relative motion. Okay, is it relative to the ground or relative to the car? Okay, note, these are important things we should take note of. An object can undergo two types of motion at the same time, meaning it is not always so that an object should move with only one kind of motion. It is possible for an object to exhibit two or more types of motion at the same time. For example, a rolling ball or wheels of motorcycles and cars undergo both rotational motion and translational motion simultaneously at the same time. We will see that in images. Look at, let's say this is a ball, it is rolling like this, so it is undergoing rotational motion, and it also changes position from here to somewhere here, so it has translational motion as well. This is why we say rotational and translational motion of a ball. Now this is an athlete, and we wrote here translational and rotational and translational motion of a bicycle wheels. These wheels here, the wheel move like this. Okay, it's moved like this, rotational motion, and then it changes position from somewhere here to somewhere here, and that is translational motion. So you have two kinds of motion at the same time. Now at this point we have to summarize what we learned today. Here is the quick summary. Motion involves a change of position of a body with time. The different types of motion studied in physics include random motion, translational motion, rotational motion, curvilinear motion, oscillatory motion, and relative motion. Examples of random motion are the Brownian motion and the irregular motion of insects around us. Examples of translational motion are the motion of a car or train on a road and the military parade. Examples of rotational motion are the rotation of the Earth about its axis, the rotation of fan blades, and the spinning of a DVD. Examples of curvilinear motion are the motion of a ball when kicked, cars along a curved road, and the roller coaster train along its track. Examples of oscillatory motion are the swinging of a swing, the vibration of plucked guitar strings, and the motion of a mass spring system. Examples of relative motion are the motion of a passenger sitting in a moving car relative to the ground, and the motion of that same passenger sitting in a car and now relative to the ground. Evaluation. Okay, these are questions you should be able to answer at the end of this lesson. Question number 1, define motion in physics. Number 2, mention the types of motion studied in physics. Question number 3, give 2 examples for each type of motion you have mentioned in question 2 above. Now here is an assignment or homework. Okay, if you go home, make sure you are able to do that. Okay, solve these problems at home. Identify 3 objects commonly found in homes and describe their motion. Secondly, investigate the motion of a pendulum in a school and explain its periodic nature. we have what we call a pendulum, simple pendulum, in a physics laboratory. Okay, you have to go there and check, look at the simple pendulum, observe its motion, and then tell us which kind of motion is that. Analyze the motion of a shopping cart being pushed in a supermarket. Compare the motion of a ball thrown in a school playground and a ball kicked when taking a free kick. Finally, describe the motion of a javelin. Here is the javelin. This is an athlete, okay, and then she threw the javelin. This is what we call the javelin, this spear. So if it is thrown in the sky, what kind of motion is it undergoing? That is the question. I hope you enjoyed this class. This is the end of our today's class on the types of motion, inshallah. Assalamu alaikum wa rahmatullah.